Hello, Algebra. Welcome to Lesson 7.4 on factoring polynomials. This word factoring you're going to hear quite often in the next lessons. And factoring needs to be thought of as like division. So I put the word like in quotes. Like, it's like division. Okay. When you think of a factor, right, and usually they're in pairs, think of two factors. Two factors are two numbers or items that multiply to get another item. So if you have that larger item and you want to factor it, you're dividing it into the factors. So again, it's like division. Okay. That's why it follows lesson 7.3, which was on multiplying, right? So now we're going to do some division. And 7.2, by the way, right? 7.2 and 7.3 were on division. Okay. All right, so let's move on. Okay, so find the greatest common factor. So we typically abbreviate greatest common factor as GCF, right? So here we have a trinomial. Three terms. It's actually a fifth degree trinomial. I think it has a name, but that's quintic maybe, but it's a trinomial, right? In order to find a greatest common factor, you have to find the greatest common factor of all three terms. All three terms. So what I'm going to do here is I'm going to break down the numbers using factor trees, if you remember, and then we'll take a look at the variables as well. So the number 12, right? So I always like to start with the smallest prime numbers. 2 is the smallest prime number. If you look at your prime numbers are numbers that are divisible by 1 in itself. So 2, 3, 5, 7, 11. I skip 4 because 4 is divisible by 2. I skip 6 because 2 and 3 make 6. I skip 8 because 2 and 4 make 8. I skip 9, I skip 10, I go to 11, and so on. All right, so I'll start with 2. So 2 and 6 make 12. These are factors, right? 2 times 6 is 12. 2 is prime. 6 can also be divided by 2. 2 times 3. Both of these are prime. So 12 would be 2 times 2 times 3. And then x to the fifth is x times x times x times x times x. So what I'm doing is that I'm expanding that term into all of its factors. Okay, now let's do the 8. So again, 2 goes into 8 4 times. 2 is prime. 2 goes into 4 2 times. The 2's are both prime. So I'm going to put the plus sign because of the plus sign here in front of the 8. And 8 is 2 times 2 times 2. And there are 4 x's here. So x times x times x times x. All right? And then we'll do the 6. So again, 2 is prime. It goes into 6 3 times. Those are both prime. Okay? So I'll put the minus sign because there's a minus in front of the 6. And we'll do 2 times 3 times 3. And then there are x to the third, which is 3 x's. And now what I'm looking for is I'm looking for the GCF, the greatest common factor between these three terms. GCF. Well, what is common? Well, I see everything has a 2. 2, a 2, and a 2. So I can put a 2 in my GCF. Now, I cannot pull out a second 2, even though the first two terms have a 2 in them, because the last term has no more 2's. So they're all done. What about 3's? The first term and the last term have a 3, but the middle term has no 3 done. 2 is the only number that I can pull out as part of my greatest common factor. And now what about the x's? Well, we take the smallest number of x's, or I'm sorry, we take the largest number of x's that all terms have. Right? X to the third is the smallest, or is the smallest number of x's. All three terms have at least 3 x's. So I'm going to take out those 3 x's. And that'll be x times x times x. And your GCF is 2x to the third. This is our greatest common factor. Okay? So really this is the answer, 2x to the third. Now as a follow-up, what happens when we actually factor that out? Okay? Well, when you pull, so this is called factoring. Give me 1 second. And again, I think we'll do this in the next. I'll turn purple. So when we actually factor out the GCF, right? We put the 2x to the third in front, and we open a parenthesis. So now everything that's left over, we just multiply back out together. So 2 times 3 is 6. X times x is x squared. Put your plus sign. Again, multiply back out. 2 times 2 is 4, and put your x, because there's one x. Put your minus sign. And then the only thing left here is a 3. And this is the factored form. This is our goal after this lesson, is to be able to factor out GCFs. Right? So a GCF is a 2x to the third. And then that's what's left over. If you were to multiply this back out, right? Let me do it in green. If you were to multiply that monomial into that trinomial, you should arrive back at what you started with. And that's a way to check. Also, notice that when you pull out that GCF, you still have a trinomial, 3 terms in parentheses. So you cannot lose a term when you factor out a GCF. So 3 terms here, still 3 terms there. All right, perfect, great. Okay, we're going to do one more question on this video. Okay, so question 2. Why is it helpful to factor out the GCF from a polynomial? All right, so again, here's this idea of GCF. So let's take a look at these 3 terms, right? Okay, so for my GCF, this is in standard form. It is a cubic trinomial. X to the third is the highest power of x. That's the degree, and it's a trinomial. Now, because your leading term has a negative, I'm actually going to pull out a negative in my GCF, okay? Now, what's going to be hard for you guys is to know what is the greatest common factor between 12, 18, and 27, right? That's hard. So what I would do is I would start with the 12, okay, and I would break it apart, right? So 12, so I'm going to start with the smallest number. So 12 is 2 and 6, 2 and 3, right? So the question is, what combination of 2, 2, and 3 can go into 18 and 27? Well, 27 is an odd one because 27 is 3 and 9, and that's 3 and 3. So notice there are no 2's in 27. So these 2's right here cannot be part of your GCF. So the GCF must involve a 3. And lucky enough, 3 does go into 18 6 times. So a 3 can be part of our GCF, or can be part of our GCF. Notice I made it negative though, right? Negative 3. And then x to the third, that's 3 x's, 2 x's, and there's 1 x's. The largest number of x's that they all have in common is just 1 x. And what we're doing here when we factor out a GCF is we're making everything smaller, and that's our goal, right? So now when we factor this, okay, now the negative's going to throw a hiccup, so watch. So negative 3x comes out in front, here's our parentheses. What's going to happen is all of your signs are going to change, right? So this minus becomes a positive, this negative becomes this minus becomes a positive, I'm not going to write it. This positive becomes a negative, and this negative becomes a positive, right? So your signs all switch. And now we divide 12 by 3. 12 divided by 3 is 4. And we take away an x, right? Because we're pulling one out, that's x squared. Okay, 18 divided by 3 is 6. Again, we already took care of the signs. And we take away an x. 2 x's minus, so we have x squared. We take away one of the x's, that's x to the first. And then here, 27 divided by 3 is 9. Again, we took care of the sign already. You could say, what's negative 27 divided by negative 3? And that's positive 9, sure. And then this x is gone because you pulled it out, so there's no longer an x. And again, the idea of why it's helpful is that this trinomial is now smaller numbers, right? It's very, very, very better. Very better. Very better. It's much simpler in math to work with smaller numbers, right? So we want to do that. Okay. So down here, a little bit of a note. Let's see what it says here before we move on. Okay. So it says factor out the greatest common factor results in a polynomial with smaller coefficients and smaller exponents of variables, right? Very important statement. I didn't talk about the exponents, right? It makes it easier to analyze the polynomial further. Also, right? Also, it makes your leading coefficient, that first number in front of the highest power of x, it makes that leading coefficient positive, right? You should, if there's a negative leading the polynomial, you should always pull it out and make it part of your GCF. Perfect. Okay, so that's the end of video 1. Video 2 is coming up.